Hi there everyone, today we are going to look at differentiation 3. So this is the third part of 3 lessons regarding differentiation, very much built on the previous 2, so we'll get cracking on what stationary points are. So what are stationary points first of all? Well, stationary points lie on a curve where the gradient is essentially 0, alright? So it can happen where it turns, or an equation turns around, or it can happen where it kind of flattens out, which we call like a point of inflection. All right, so what I mean by a point of inflection, if you can see my cursor hopefully, so what a point of inflection, we're going to go up, it will flatten, and then we're going to go back out. All right, so that bit in the middle, it would be a stationary point. But similarly, if you've got a curve that goes up like that, then the stationary point would appear at the top, and similarly, if you've got a curve that goes like that, then the stationary point would be at the bottom. So a stationary point is where the gradient is 0, okay? But because we're talking about the gradient being 0, then essentially the differential of the equation, i.e. dy by dx, would equal 0. All right, so if we're looking to find a stationary point, then we can just differentiate the equation, make it equal 0, and then solve it. Simple. Okay, so let's look at an example. And remember, we are looking to find a coordinate, so we will likely to be looking for not just the x value, but the y value as well. All right, so here's an example. We've got a curve with equation 3x squared minus 24x plus 2. And the first step we're going to do is differentiate that. So dy by dx. All right, so if you recall from the previous lessons, hopefully you've looked at those. The 2 comes to the front and times by 3, so 6x, and then just drops by 1. So it'd be 6x to the power 1, or just 6x. And then because of the minus 24x, so the x just basically disappears. So we're going to have 6x minus 24 as the differential. Okay. Now, like I said, we make that equal to 0 because we're looking for the stationary point on that. Remember that this expression here, 6x minus 24, is the gradient at any particular point, but we want to find the x value for when it equals 0, so we make it equal 0. So 6x minus 24 equals 0, so take the 24 to the other side, it becomes positive, then divide both sides by 6, and of course we've got x is equal to 4. But we're not done at that point. Yes, we found the x value, but we also want to find the y value. Well, if you recall in previous ones, when we're trying to find the coordinate, what we've got to remember is this x value goes into the original equation to find the y value. Okay, so we're going to substitute the value of the 4 into the original equation. So we've got 3 times 4 squared minus 24 times 4, and then plus the 2. And then just multiplying that out, so 3 times 16 is 48, 24 times 4 is 96, and I add the 2, and that gives us minus 46. So our coordinate of the stationary point, and it clearly is only 1, because it's a quadratic, and it obviously take that shape, is going to be 4 and minus 46. So that is the coordinate of our stationary points. What about turning points, maximums and minimum points? Okay, so turning points, like I said previously, can be maximums, it kind of goes like that, or it can be minimum, where it goes like that, or of course it can be a point of inflection. So we're just looking for maximums and minimums at this particular point. So here it says it can be defined as a stationary point can be defined as maximum or minimum, but you obviously need to consider the shape of the graph to decide if you found a maximum or a minimum point. So a positive quadratic tends to take this particular shape, so it kind of goes down there up. All right, and by all means do look at graphs and practice and familiarize yourself with the shapes of graph. But a positive graph, so just x squared or 3x squared or 4x squared, positive will take this shape. Okay, if it's a negative quadratic, so minus x squared or minus 2x squared or whatever, then it will go upside down. Okay, so like that one. And then of course you've got a cubic graph where you will have potentially a maximum and a minimum. All right, so 2 different shapes here. Okay, now this one's more complicated because we've got to determine which one is which. And of course, we also need to consider the fact whether or not it actually just has a point of inflection and just goes flat and doesn't have either. So that one, the cubic, is certainly more complicated than the quadratic ones. Okay, so let's have a look at this particular example. Well, hopefully you can see right from the outset, when it asks us to find the turning point and determine its nature, that we've got a negative x squared. So what we're going to have is this particular scenario where we're going to have a maximum. And then we're just going to do what we did 2 minutes ago which is basically differentiate it, make it equal 0, and find the point. Okay, so y equals minus x squared plus 8x plus 9. When we differentiate that, we have minus 2x plus 8. So when 2 comes to the front, the negative stays there. And of course, we drop the x and the number disappears. So we now just need to make that equal 0. So for turning points, like I said earlier, dy by dx equal to 0. So we'll just make minus 2x plus 8 equals to 0. Rearrange that, so move the 8 across to make it minus 8, and then divide both sides by minus 2, and we've got x equals 4 again. Okay, right, so with this one, like we did previously, we need to substitute the value of x equals 4 into the original equation to determine the value for y. So let's do that first of all. So substitute value of 4, and you see we've got minus 4 squared plus 8 times 4 plus 9. Again, you'll notice I put these in brackets. I mentioned it previously. That's just to make sure that I don't get here confused with doing minus 4 squared. So minus 4 times minus 4 is 16, but of course it's minus 4 squared. So it's minus 16 there. So we've got minus 16 plus 32 plus 9 equals 25. So my coordinate is going to be 425. And then, of course, it does ask in the question about determining its nature. And that's what that means when it asks you to determine its nature. Is it a maximum or minimum, really? That's what, or in certain cases, like I said, we haven't really touched upon. It's more A-level, whether or not, obviously, the maximum or minimum. And like I said, it's more likely to be A-level that you discuss whether or not it's a point of inflection. Okay, I won't touch upon that today. So y is negative, so y is a negative quadratic, so it's going to take an N shape, so it's going to be a maximum point at where x is 24 and y is 25. So at the coordinate 425, it is a maximum point, and of course it's a turning point as well. So the final element of differentiation is just looking at kinematics. Now kinematics is extremely popular in mechanics and will come up at A-level without a shadow of a doubt, but it's something that also occurs in GCSE or iGCSE, so it's worth kind of touching upon it this time around. So first of all, displacement is normally given the letter s, and that can be given as a function in terms of time t. So what you might think about is, well, when will displacement and time come into play? Well, displacement is similar to distance. Well, distance and time comes into play in relation to speed. All right, but the letters used are the ones that are widely used in formula, which is why we're introducing them to you in this particular lesson. So displacement is usually s, and time is t. So velocity is the change in displacement over time. So it's the change in distance over time, So using the correct letters, what we're talking about is ds over dt, which of course is a differential, which is what we're going to be using to work out kind of questions in relation to this. So velocity is the change in displacement over time, ds over dt, and you can see it's given as a formula like this. So v is equal to ds over dt, and so to calculate v, you've got to differentiate s, all right, with respect to t, of course, but we'll come to that. Acceleration is the change in velocity over time, all right. So when we've figured out the first one, which is v here, if we differentiate it again, so the new v with respect to time, then we're going to get acceleration. So acceleration is dv by dt. Now in A-level, you may come across this as called the second derivative, but for now, there's two separate formulas just to kind of utilise. All right, so if we're after velocity, we're going to differentiate s with respect to t, and if after acceleration, we're going to differentiate the velocity with respect to t. Okay, so that's what we're going to do. So let's look at an example in relation to this, because it's important that you see it in practice. But if you've learned differentiation, then there should be no issue in you tackling these kind of questions in exams. So s is the displacement, equals 5t cubed plus 7t plus 3, where t is time in seconds. So you can see we've got meters, and then we've got seconds, so we've got units in relation to this, but you'll notice this word displacement, which is a little bit different to what you may be familiar with. Rather than saying distance, it says displacement. Okay, but again, the s being used. Okay, so to find the velocity, we'll just differentiate it with respect to t. All right, so it's probably what you're familiar with now. So find an expression for velocity. So literally just for, differentiate it. So s equals 5t cubed plus 7t plus 3. And when we differentiate that, the 3 comes to the front, times by 5 gives you 15, and the power drops by 1. So 15t squared. And then here you can see that just because it's 7t, it becomes 7 and the number disappears. So 15t squared plus 7. So that is an expression for velocity. Okay. Now if we're looking at acceleration, we're going to basically use what we've just done, because we've got v here. And if we go back to this, then we just differentiate v with respect to t. So we just differentiate it again. Hence why it's sometimes referred to as a second derivative. But we're going to follow the same process. So a is dv by dt. So the 2 comes to the front, times by 15 gives you 30, and the power drops by 1, so just gives us 1, which is just 30t. And of course the number just disappears, so we've got 30t. Alright, so that is an expression for acceleration. Now the chances are this next bit is where it's leading to. They're probably going to ask you some questions in relation to the 2 expressions that you've put together, or maybe just the 1. So here it's talking about acceleration. So because it says find acceleration after 6 seconds, well, it talks about t in time in seconds. So we're just going to use the 6 as t and substitute it in. So substitute t equals 6 into a, which is here. So a equals 30t, which is 30 times 6, which is going to give us 180. And we do know the units. So this is meters, and we're talking seconds. And because it's acceleration, and we've done it twice, it's 880 meters per second, which is why you've got the -2 there. So 180 meters per second. Right, so that is kinematics. So we're not going to go any further than utilising kinematics at this particular stage. That's as far as it goes in terms of iGCSE, but it's certainly an introduction and worthwhile knowing that that is utilised at A level as well. But it's enough for now. I would suggest you probably go and practice some of those questions and just get familiar with the notation of displacement, velocity and acceleration, and the fact that you just need to differentiate them once for velocity and then twice for acceleration. Okay, I hope that helps, and thanks for listening.